Look, that's probably all I need to say. Luke, thank you for coming. Can we make Luke feel very welcome?
All right, who's excited to learn about vertical slice architecture? Yeah, all right, that's good to hear. All right, so yeah, as Todd mentioned, yeah, we're doing vertical slice architecture 0 to hero. And I titled it 0 to hero. It's an overused title, but my main pain with a lot of the training online is you usually just see the folder structure and the training is just like, hey, everything you need to do the things in the folder, and it just stays together, grouped by business feature, and that's it. And you know, in an enterprise app, are you gonna like replicate database access every time, every folder for that? Like, we want to find out actually how to use this from not really knowing about it to a pragmatic middle ground, and what the theory is. So, with that being said, what we'll talk about is the history of VSA, so where it came from. Obviously, Jimmy Burgard termed it, but there's some history there that you might not know about. Then we'll go through basically all of the theory that there is to it. And we'll go through 2 demos. One is going to be a simple CRUD app, so just some data access, throwing data to a database and fetching it out. Not really much business rules going on there. And then we'll look at a little bit more of a complicated app and how the code bases might look a little bit different. Then when we wrap up, we'll just talk about, hey, like when should you actually use VSA? How do you figure out if it's a right fit for you or not? And then finally, we'll just link to some resources and some further learning to wrap up. So without further ado, I shall introduce myself. I'm Luke Parker, a full stack engineer at Revive Financial. I've been really interested in architectures for a good while. I deep dived into, coding patterns, clean architecture, vertical slice architecture. At the previous gig, we did some clean architecture training, so some contrarian opinions. And I've spoken at DD Brisbane, NDC Sydney, .NET Conf before. You can check out my GitHub or personal site if you like. So, history of VSA. It all started in 2015, actually. It was under a slightly different term. It was called solid architecture, which is interesting. So Jimmy Burgard did a video. You can find a link to it on Vimeo. I've got a slide at the end that links to all these resources, so don't worry about trying to get any photos if you're interested. And it basically linked all of the solid principles. Instead of at like an individual function level, he kind of used the ideas and concepts and talked about them at a architectural level, which was interesting. So going through it, single responsibility principle, right? It's just saying, hey, do one class for each feature and concept. I'm simmering it down. He's got the longer talk, goes in depth, but I'm kind of giving the higher level overview of it. Open close principle, we extend through doing cross-cutting concerns and don't really modify stuff. So decorator patterns, you can attach middleware, you can attach attributes, you can attach that kind of thing to extend behaviors instead of modifying them. Just don't do inheritance, we don't want to worry about that one. And I'm not going to try and pronounce Liskov, we'll try it. ISP will do CQRS but not call it that, just do separate classes, that's it. For dependency inversion, we'll just only invert actual external dependencies. So it's not saying, hey, always make sure your classes inject things and do it all of the time. It's more of a pragmatic thing of for databases or third-party APIs, things that might be I/O, maybe invert that into a class. Now, I simmered down and butchered most of it just to be able to get it into one small slide. You can watch the video if you want to hear Jimmy go far more in depth on it. But that's basically where it started. 2015, it was called Solid Architecture. A lot of it did look very much so the same as the VSA talk that came next a few years later. This was really the start of it. This is also the blog post Jimmy made that basically everyone has to link to because that is where he coined it. This is the start of it in 2018. It added a few extra things from the original solid architecture. It specifically called out, hey, let's do CQRS and expanded on it a bit more. An important thing with CQRS is it doesn't actually mean you need like a separate database for reads versus writes. It is just like the logical separation for a developer, not as much as how the system works. So when you hear CQRS, you don't have to separate databases and do weird things. It's just a way to break it up. Okay, we want vertical slicing to make code easy to modify, which at an architectural level, that sounds weird, like it seems very subjective. How is it easy to modify code? And this is kind of the start of where VSA is different to a lot of architectures. It's more actually about kind of your development patterns and processes than it is specific technical ideas. So another thing he mentioned in that blog post is, you've got to do red, green, and refactor, and not skip the refactor part. So if you haven't heard of that, it basically means you write a test for a feature you haven't done yet, it fails, then you go and code away, do maybe refactoring, maybe not, maybe copy paste code, who knows. Then your test passes to at least kind of show that your feature maybe works, and then maybe clean up your code to keep the green passing, but get it ready to commit. But again, this is saying, as the architecture, right, as the guidance on how to do VSA, make sure you refactor and keep code well as you kind of hack away. On that refactoring note, another thing he mentioned is code should be pushed down. Now, I'm going to talk about this a lot more with actual examples, so it might not make sense at the moment. But as you start with maybe hacky code in your little slice that only needs to do one thing and it's isolated in that one little feature, as it maybe needs to be shared more and more and things might maybe depend on it, we want to shift it down into maybe services or a domain that's deeper in the application. But we do want to start up at a feature code and then maybe push down. And I'll talk about that in a second. But this is where Jimmy kind of ended up with. We can look at the blog post. I have it up over here. If you haven't seen it, there's a link at the end, so definitely read it. But this is all of the theory that Jimmy goes on at a high level. Now, he does do talks. The videos do show a little bit more. Like they show cross-cutting concerns and some extras. But definitely read through this in your own time. Okay. So, bringing it back to architectures, I wanted to make a diagram that kind of looks like this, just to juxtapose like the difference in thinking. So if you haven't seen it before, this is the clean architecture diagram. It shows layering, but based on technical concern. So you have your domain at the bottom. It doesn't know about anything external. Then above it, you have application use cases that are specific to your application. So how do you do something using the domain? Then maybe you have technical concerns above that to how do you wire up that actual running application. So maybe a web API linking into your logic that's specific to your app. And then above that, you're injecting in maybe databases and other things. Okay, and those all flow inwards. So this architecture, just purely on the flow and ways things depend on each other, is a technical layering. VSA, this is an image from his blog post. Things don't actually flow in that way. You just group it all up and you instead think of things in terms of their business function and the feature itself and what's used there. So it's just, again, it's like it's vertical versus horizontal. It's a 90-degree turn in thinking. It's kind of weird, but you can get your head around it in a second. So again, another image from his blog post. You, in one feature slice, get orders. It might be very simple. It might be CRUD style. You might just use EF core and do some logic and shove it in the database just in one code class, and that's it. In this invoicing example, maybe you decide, okay, it's complicated. I want event sourcing, and I want the audit trail that comes with that, and the nice write model with an aggregate root, and all these different things. And you can kind of make that decision specific to feature folders, slices, groups of them. You can kind of pick that pragmatically. Whereas if you're looking at clean architecture, right, you can do that to some degree, but it's a lot more opinionated, and you should just do everything this exact way. If your question is, where do I do data access? It's do it in infrastructure in this way. So VSA is a lot more empowering the developer to decide where things should go, whereas other architectures are a lot more cookie cutter, which is interesting. Now this is a funny little diagram. I wanted to mimic that diagram. And what I did here is just, I wanted to use the darkening of color to show how much reuse and how much risk and scope of, if you change, say the domain, which is reused across your whole application in vertical slices, you might impact all use cases. You might impact one. If you change one use case, you're only impacting that use case. If you change code that is common among a feature folder, so there might be more than one use case in a feature, well then you impact a few use cases, but not the rest of your application. So the more inwards to your application some code is, the more risk there is to that, because a lot more things depend on it, and therefore you might want more testing in those core bits of your app, but as you get out, there's less risk. You can have maybe more hacks, more questionable code in use cases. If they're only used once, you code it once, it's fairly stable. Whereas a domain, if you change your very fancy from before this invoice model that it's financial information, it's kind of important. If you mess with that domain model, the aggregate root, you might impact a lot of the system in a lot of unpredictable ways. And then another interesting thing, use cases know about a feature folder code that might be common. So you might have a service. Let's say you have a to-do feature folder and some CRUD endpoints. You might have like a to-do service that has some logic potentially, and all these use cases can reuse that one service. And then your domain, anything can access that. But a decorator pattern, the use cases don't know about it, right? It's attaching it on. That's that whole solid open to extension but closed to modification thing, which is interesting. Your decorator pattern usually is middleware or pipeline behaviors. Let's say you want to log performance. Your use case code doesn't care that it's being logged on how long it takes to run, so it's kind of external to those things. But it's still high risk. It might run on every endpoint, or it might run on one. So your risk involved with changing code in your cross-cutting concerns of your domain is the highest, which knowing the risk factor involved is kind of important with VSA for reasons we'll look at in a second. Another thing, a quote directly from his blog post, is that we should minimize coupling between slices and maximize coupling within a slice. Now, note that it's not don't couple between slices and only couple within a slice. It's, again, empowering a developer to make the right pragmatic decision and saying, in general, try to keep the risk factors in check, try to keep use cases isolated, but are you going to write a new DB context for every single use case? Like, yes, you could do that, and it might be safer, maybe, but like you're bringing in so much code for no reason, you can accept that, yes, everything will reuse this one, maybe data access model, and if I change it, everything might break, but maybe we can figure out how to strike a balance between risk and how coupled or decoupled we want things to be. So, yeah. We can have one DB context, use the F-core across everything. I think that's fine. We can repeat code. We don't have to immediately build lots of abstractions to reduce a few lines of code, and everything depends on some God class to save a few lines of code. You're allowed to replicate code, but not business logic in general. So if you're doing boilerplate, like, yes, you can improve it a bit, but it's fine to repeat what might look like business logic, but is actually separate business rules, even if they're similar. So again, it's empowering the developer. You make that decision on, is this actually the same business rule, and should I make two use cases run the same code, or are they actually separate processes that should run individual code? So you're allowed to repeat code, but figure out where that lies. Should it be in the domain? Should it be shared within a feature, shared with everything, or just for this one? Create an invoice. It might fetch different data or similar data with a different report, but the data it picks up is specific to itself. So maybe it's fine to build a query just for fetching an invoice. Again, based on this quote, we probably want our domain, which is shared among everything, to be somewhat pure and easily testable. So we probably don't want to inject data access and external things to a domain. I don't think that's too crazy. The other thing is, yeah, you might be writing some code in use cases, but you don't want to start with lots of abstraction. One of the big pains I hear with clean architecture, and I think everyone would generally feel the same sentiment, is you want to build a simple app. There's nothing too crazy about it, but you immediately have to touch basically 8 files to make one endpoint. You need maybe a domain model in the domain layer. Then you go to the application layer, you make a query handler class, a validator. You might be doing more than 8 files. Then you go up to the presentation layer, and it goes on, and then in the test projects you do the same thing. It's a lot of code. You immediately have to do this level of abstraction for everything. Whereas in VSA, potentially, you don't have to start that abstracted. Maybe you slowly reach the right level of abstraction as your application goes through time, which we'll look at a little bit later. tying into that, the whole thing with dev empowerment is take that pragmatic response to duplication. You might start with a business rule that is in a use case, but then you do identify that it should be shared. You might be building that first feature and think, maybe I'll reuse this. And if you want to abstract that right away, maybe you do, and maybe you build the next thing and it's easy. But as a general rule, if you're always abstracting, you'll end up with a lot of abstraction as your app evolves. Whereas why not just start with really simple, really easy readable code where you just know what's going on, and when you feel the need that it actually is going to be used, then you can pull it out, and then you just end up with as defactored code as you can. Yeah, so I don't think a DB context per use case is a good idea. And the other thing, some people are like, well, you can't share any code. That's not how you do VSA. You have to have everything contained in the folder, otherwise it's not. I don't think that's right. And if you read Jimmy's blog posts or his videos, I don't think that's his intent either. So just to recap, normal software architectures like clean architecture, right? They're very opinionated. If you have a question on where something goes or how it's done, there's usually an exact answer, especially with clean architecture. You usually have that high level of abstraction, which may or may not be the right choice, depending on your app. And it's really about the technical pieces. Whereas VSA, right, it's opinionated in how you actually do your dev loop. So red-green refactor that it mentioned in the blog post, being pragmatic, making decisions. A lot of it shifts onto the developer and how they should do their work, not how they write their code. It lets you have your own flavors and decide how much testing, how much risk you want to take on, how much code duplication you want. You can kind of decide as a team and as an individual what variables you care to optimize. Maybe you care about how fast it is to get a feature to market versus you don't really care about the cost to maintain it in future. Or maybe you really care about things not regressing. You can kind of make that decision, which is interesting. Okay, so the dev loop, what does it kind of look like? We talked about a few pieces of it from the solid architecture, then the VSA blog post, and it's been a bit scattered. So we might get a ticket to work on. We'll probably jump in and immediately write a test if it's new functionality. If it's a bug fix or change like that, maybe you want to test. We'll just assume let's say it's a new feature, right? You probably want to then jump in and think like, what is my feature going to do? Let's say it needs to save some data, then send an email to some internal business users. But or a dev on your team mentioned that, hey, we've already got something that sends emails to our internal business people, and it's done over here. So, okay, there's code here. I know that it already exists. Let's just investigate what's there. Maybe this email sending code is just in a use case, so we're kind of starting to think, okay, I want to increase the risk factor, the scope of this email sending code. It might have to be pulled out and shared, or maybe it's not actually viable to be reused. You kind of have to make that analysis first. Once you do figure that out, then you start building. So maybe you have to refactor this piece out, or maybe you have to do fresh code. That's kind of up to you. And then at that point, we want to refactor our code. So clean it up, make sure we've thought about all the code we write and how shared or not shared it should be. And obviously merge and then just keep coding. So that's kind of the cycle. Now the red-green refactor and looking at what's already there, that doesn't have to happen once. You might go through that cycle a few times on one feature. You might write it more than one test, right? You might figure out new requirements as you code it. A lot of that is, again, in the developer's ballpark or court. It's not just, write a service in the application layer, make this command handler call the service. Like, it's not all decided for you. You can decide what's optimal for your business. Now, the code also isn't static, like I mentioned. In clean architecture, you generally, once you have your handler that calls a service and does a controller that calls into it and whatever's there, it generally stays like that, and the way it looks generally stays the same. Whereas with VSA, usually your code will start out as a transaction script. And if you haven't heard of that term, it's, I don't know if it was coined by Martin Fowler, but he definitely has the blog post that everyone will link to. And what it basically means is you start with one function that does everything you need to achieve the thing, and then that's it, right? You grab your data, you run some logic, you do some validation, return good, return bad, and that's it. It's a unit that does everything, right? And that's the start. Let's say I'm starting a new code base and I'm just writing some endpoints. Well, obviously there's no logic to refactor, so you will write just feature slices that probably start out as just a transaction script. It's very simple. You're not abstracting anything because nothing uses it. It's in isolation. There's no need for it to be reused yet. As you progress over time, maybe let's say it's a financial system that you're starting to get some finance data in here, but you're doing lots of reporting. You might start refactoring some of these logic pieces into a service layer that's maybe grouped to just the feature, or maybe it's global to the whole application. It'll start to move down, which is that thing that Jimmy's blog post mentioned. Your code moves down. It starts in a use case as transaction script or just plain code. Then you start to refactor as it needs to be reused. Now, code might just be written as a transaction script and it might just freeze there. If your logic, your business rules are only needed in that case, then it might just stay there, and that's great. You didn't waste any time building a factory generic repeater pattern decorated blah 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 word. That's all tech debt. Having code is expensive, right? If you write a transaction script and it's 100 lines of code and it gets the job done, then great. I'm never looking at this again, maybe, or maybe fixing a bug once. I can still read it. It's very simple. You can follow the path. Abstractions come at a cost, right? If you build a highly abstracted system and it's cool, it works, and then 6 months down the line you have to pick it up again from not looking at it, that takes development time to get up to speed with it, understand it again. It's expensive. And this architecture lets you incur those expensive costs for the code areas that need, that warrant the cost. So, okay, let's say code is starting to be reused. Some logic is needed in more than one feature. You might build a service. Again, it might be common to more than one feature folder. It might just be common to one feature folder and several use cases within it. But once you start reusing logic more and more, even more than a service layer, you start to get into that domain-driven design land where you start to have your entities have logic and be pure and go down that route. Now this talk, I'm not going to do anything domain-driven design related. There's lots of talks and resources out there. But you can reuse code with a service and lots of things use that, but then you can go even further and go in the whole DDD land. So I will show some samples that show some different tiers of just a transact script versus a service layer versus a DDD style code base, so you can kind of get a feel for what they would look like at different stages. But this is really interesting, right? An architecture traditionally just means you do these things in this way. This is how you write the code. Whereas this architecture, yeah, it says you do CQRS and you do these general things, and things generally shouldn't be tightly coupled. Like, yes, it tells you some of that, but a lot of it really is just in the way that you work, which I find really interesting. So, simple CRUD up. I mentioned the painful thing is I just want to build a to-do app. I think everyone's seen architecture examples that are a to-do app, and it's highly abstracted. Now, it's hard to convey an architecture with a simple example that shows the complexity and what's warranted for it. So, clean architecture is great. I just have to say that. But sometimes maybe not the right choice for something simple like a to-do app. So, I have cooked up an example of how you'd implement VSA. So this is what I use in my personal apps. It's one way to do it. As I mentioned, right, it's not as much technical as it is the way you work. So if you want to replicate the steps I do, you can run this command. Again, I will show you the resources at the end, so don't worry about it. And then we can spin up a new app. Here, I'm not going to run it. I've already ran the command, so we don't have to wait. But this will spin up this exact code. And I'll walk you through what this solution we've got out of the gate here. We've got one source code app. It's a ASP.NET Core application. Now, is that big enough for everyone before I keep going? Yeah, thumbs up, cool. We've got one runtime application here and a few tests. I'll look at the tests in a second. And we've got three things. Now, the main thing when you're working in VSA is thinking about how reused this code is and therefore the risk involved when you change that code. So the domain, that's global to everything. So this is a to-do sample, which means it's just 4 endpoints, create, read, update, to-do entities, and that's it. So this domain is shared among everything. So this folder, whenever you're working within the domain, that's high risk. So I need to care about this a little bit more. Your common folder is also shared among everything. This might be your database access, some decorator patterns. Let's say you're doing performance logging or audit trails and things like that on every request. You might put something like that in a common folder. So that's what I've got here. I've just got a DB context, for example, with just one table. That is the hint, yeah. Now, to show the domain, we've got some fun features in here. Has anyone heard of Virgen before? Hands up. No one's heard of it. Interesting. So if you, who's ever applied like an integer ID all across their database, and you've got a function that takes in 2 different IDs, and you apply, the product ID accidentally in the person ID, and you don't know about it, right? Because your compiler doesn't yell at you because an int is an int, and all is well. Yeah, a few of you. So this library is very simple. All it does is essentially make value objects around a primitive so that at compile time you can find those mistakes very easily. So for example, this to-do ID that's used in the to-do entity is actually just a GUID. Now this library is open source, free, all of that stuff. You can use any sort of primitive. My typing is not typing. There you go. So you can change this to be an integer, and the source generator will run behind the scenes and generate you all of the pure code to be an integer. That's fine. But I'm using GUID code here, so let's stay using a GUID in this case. So Vogon lets you basically use primitives exactly as you'd expect them to be. So it's compatible with EF Core, it's compatible with OpenAPI coming on out, it'll understand it as a GUID, everything there works fine. There are some caveats, you have to wire it up, but once it's wired up for everything, and then you just get the protection of not accidentally applying IDs. Like, it's just a net positive, right? Once it's in there, it's one extra line of code, and then you're safe. So that's a fun little tool that you can take away from today. But yeah, here we've got a domain with an ID and then just a name for the to-do, what you want it to do, and whether you've finished it or not. Okay, that's all we've got here. Speaking of Vogon, I can show you here, we aren't actually saying anything weird. We can configure it as we'd expect. Hey, here's a key. Here's a constraint that the name should be only so many characters, and maybe some database defaults, which is the nice thing with Vogon. You wire it up once. The source generators look at your code, figure out what EF Core configuration you need to apply, and it just works. And that's done. I can even show you. In your DB context here, the source generator just spits out some code. And if you haven't seen source generators in a while, you can actually very easily look at the code it spits out these days, which is really, really nice for static analysis. So we can even see what it adds in here. It says, hey, anything that is a to-do ID, it has this converter that it created. So you just don't know about it. It persists to your database nicely, and you're off to the races, which is nice. Okay. So that's Vogon and the domain. This is highly reused, and that is why I'm adding in things like Vogon in here. So the to-do entity is shared across the whole application. It may or may not be, but since it will be used everywhere, I want to add in as much pit of success, shoving I can do as possible. So just never make a mistake with the ID. With static analysis, great, I'll add that in. In a use case that's only used once, maybe it doesn't matter. Okay, so let's look at the feature folders here. We've only got one feature, like I said, it's just a simple demo of showing how to do a CRUD app. Okay, inside of here, we've got 4 files, one for each endpoint, and then a common folder, so shared code among that feature, which if I bring back this little thing here, right, it's that second ring. The domain is shared among everything. A feature is only shared among its children use cases. Okay, so it's still risky, right? If I change something here because someone wants the update let's say the update depends on your feature common code, and I change it not knowing it is reused, then yes, you risk breaking things by accident. But in these code files, what have we got in here? So this example is using fast endpoints. There's reasons for that, but it's kind of out of scope for this. But just know that we're using fast endpoints to have one file, have model binding working nicely for CQRS and our request objects. It just works nicely in the VSA story. So that's why it's used here. So what have we got? Following the Reaper pattern, which is big in fast endpoints, all the Reaper pattern is just having a request, endpoint, and response model. So, okay, we've got a request model here, taking in a to-do ID, so that Vogon primitive that is actually a GUID, but we're saying, hey, I want a to-do ID. That comes in. Fast endpoints, like I said, these value objects work nicely, even with a JSON API, it understands it. That's all we're taking in, right? Then coming down to the query here, so CQRS, we're just naming it a query to denote that this fetches data, doesn't update anything, doesn't run any business, write logic. We then say it's an endpoint, so it's kind of similar to Mediator where you have a request and then an output, but we're just tightly coupling within this slice to what it's needed for, which is a HTTP API. So we're saying, yes, this is a okay, I can't find the namespace, but hey, this is a OK response, right? It's a HTTP response of this type or a not found, and it takes this in, okay? Fast endpoints, this is configuration from them, so it binds nicely to this value from your request objects. So if you do minimal endpoints, you might have seen a lot of the demos, which is similar to fast endpoints in the way that it's like new and fun and small amounts of code. If you've used minimal APIs and tried to do it for something non-trivial, you've probably tried to do route binding, but then into a request object, where maybe you're doing a post and you've got an ID in the route, but then you've got additional fields in your request body, and then you want to bind it into an ID field on the body. You just get weird replication. You have to fight against doing code yourself, whereas this library just handles it all for you. Hence why it's really nice. And then in here, right, you just have what we called a transaction script before. It just does everything to get the to-do. There's no service call because it's a basic CRUD app. In this case, we'll query the to-dos table that matches that ID and project it to a DTO, so we'll look at that in a second. Find it. If it's not found, then okay, we found nothing. If it's found, then return the value. And that's it, right? We're not doing clean architecture where we need a service for it immediately and we need 4 different projects and random stuff. You can decide, okay, well, this is a really simple app. Maybe it's a hobby project at home. We only need like 10 endpoints. There's a little bit of logic somewhere. So maybe you have 1 service total and then the rest is really easy transaction scripts. It's up to you as the developer. Okay. The other endpoints, I won't go through them. They're very similar. It's a request object with a response type. In this case, there's no response. It's just a no content response, right? But it all follows that same structure. Now, you don't have to do this, right? VSA, again, empowers you to decide how each thing works. So maybe you want to use a controller for half your app. I don't know. You can make that decision. But some consistency is nice, and you can decide that, again, as a team. If you're working in an enterprise scene with VSA, you probably will want to discuss with your team how you want to code and how you all agree coding should look. And maybe there's always exception to the rule, and maybe business pressure for something to come earlier, or there's always weird things that prop up, and this definitely can accommodate it. But you definitely always have to kind of, I think, agree as a team when you're working together in an architecture like this for things out of the ordinary. So let's look at the feature common code here. There's just one thing reused in this CRUD app, and that's the response object. So we could return the domain model if we wanted, but I figured in line with the Reaper pattern, it's best to just call this a response. And even though it is one-to-one in this case, I do just like having that be separate. The other thing that is next to this to-do response is the mapper for it. Now, has anyone heard of Mapperly before? Hands up. couple of people have heard of Maply. Anyone heard of AutoMapper? Hands up for that. A lot more for AutoMapper. So I don't actually have a link to it, but it's probably a good resource. Wait, it might even be in here. Ah, yes. I did do a write-up on a lot of the different mapping projects and why they're around and some of the pain. There's a lot of bagging on AutoMapper and the modern alternatives and why pain might exist. But essentially, yeah. Yeah. Well, he even bags on the usage of AutoMapper, for example. It's like people are trying to add business logic within what was meant to be a convention-based mapper before we had things like generics. AutoMapper is very old. So Maply here is the one I'm using, and it's a source generator that does what AutoMapper is intended to be for, and that's for convention-based mapping, but it creates source generators, which in the blog post I articulate why that's good, but it's good because it gives us the static analysis. We can actually see the usages. With AutoMapper, I might see an unused property and nuke it, and then, oh crap, everything broke. Why? The static analysis said it's fine. I got no compile warnings. Well, here, if I delete, say, a field that something might depend on, well then we might see it go from 5 usages to 0 usages. And this is just way nicer. Again, pushing you in the pit of success. We can get the static analysis and we can make it harder for you to add in business logic. So, okay, for my personal apps, I like that. I want to know what fields are used genuinely rather than weirdly. And again, with source generators, you can actually look at the real code. So in here, the extension method that it creates generates pure code, right? You're not getting any weird reflection performance issues if you care slightly about your coding performance and how your app works. It's nice to care about performance and take pride in your code, and knowing that it is just running this, that's pretty awesome.
I have just out of curiosity
Yes.
question. Almost everything seems to be source generated. I haven't caught if fast endpoints are also source generated.
I don't have to repeat the question because you got a mic, right? Awesome. A lot of stuff is source generated in here. In Rider and Visual Studio these days, you can see all of the source generated outputs. So if I can expand this here, under your dependencies and then .NET and then source generators, you can see everything that's outputting code. So Vogon is outputting these files, some EF stuff, the to ID. Maply is outputting stuff. And then fast endpoints is also source generating stuff. And that is just what basically what endpoints you've got. Normally, like Mediator and whatnot, we'll have to do some discovery at startup, but here we've got a source gen for it. Yeah.
Awesome.
Nice. Cool. So jumping back into it, the to-do response, the other thing that I didn't show yet is, just like AutoMapper, one of its best features is that whole project to method that you can use with EF Core, which basically just automatically selects out database fields to the DTO you want out, which is really awesome for not accidentally downloading every column for no reason. It's got the same functionality. So here I just say I want to, for the to-do iQueryable, have a way to project that into the response DTO. And you can literally just see the code that it generates. It selects that iQueryable into that object you wanted and then select those fields. So it works very natively with EF Core, as you'd expect. I mean, as you'd be writing this code manually, right? It's based on the structure of your code and you can see it. So that's fun, and it's in the common folder, right? So this DTO is reused. Okay, so if I change something in this common folder, I know it impacts everything in the feature here, right? You've got to be able to identify the risk and how reused VSA code is fairly quickly. So for example, here we just return a created URL in a create command. The get query, we might select our filter, but then run this Maply projection for our DTO and then return it. And then maybe in the update, this is also reused. We might select out just the raw value in this case. Oh no, here, to response. So we're doing it in memory in this case. Okay, interesting. So that is all of the source code for a to-do app, right? It's 4 files. We're sharing the DTO because there's no point in just copying 4 fields. Let's say I add there's one table, right? Let's say we have lists of to-dos and we have a list ID and we want to add it everywhere. If I didn't share this one response, then I'd have to edit 4 response objects in here just to add one ID, when probably just that linking piece, I'm fine to allow that to be reused, right? But that's a decision. Maybe you're not okay with that in a different feature. Maybe it's a feature that touches PII or finance data or any private info passwords. Maybe you just want to be a little bit more specific with it. That's up to you. But this is really, I think, the minor piece of VSA. We've talked about kind of the understanding the risk and the reuse of code and where that is in your application. But once you have figured out the risk of a given area of your code, you probably want to remediate as much as that as you can, or protect against regressions as much as you can. So you definitely want to be writing unit tests for your domain. In this case, we have no domain logic, so I don't need any unit tests. It's just a POCO. So in this sample, I decided there's no need for unit tests. We could maybe unit test some of this common code potentially, but I didn't see the value in it. Okay. The other important thing, which is probably your starting point for most of these features, so back to the, wait, we can zoom out. Yeah, nice. Back to this loop. Let's say you're writing a new feature. If you've done TDD, you've probably seen where you write minimally passing or failing tests and then maybe expand it as you add requirements. So we'll start with an integration test that just checks that, hey, you get a success code, and then maybe that some fields went through or something like that. So integration test is definitely where you want to be starting with. So I decided that's the right case for this app. So let's check it out. It uses a lot of the modern ASP.NET Core features, so like the test server, the web app factory, test containers, so it spins up a Docker container for each test and gives you a fresh thing, all of those features. But all this test does is, I post to a URL some JSON. I could manually provide the JSON, but I figured it's fine to reuse the request object here. You might decide not to, but then you do some assertions, right? It should succeed. It should give me a location header on where that thing was created at, and the created URL should actually contain a GUID. And that's an assertion, right? Now the integration test covers a lot of things implicitly. It's explicitly saying when I create a to-do, it gives me a GUID in the URL output on the header. But it's also checking that, hey, this endpoint is registered correctly. The mapping in from my request object maybe works. It at least doesn't throw an exception. I don't know if this value is going through yet or not, but it at least doesn't throw. We're saying there's a created response return type. So then we're at least, we don't want to jump in there. We're at least getting to the point we're running this code. So, okay, that's proving that at least we can inject appdb context. We're probably checking that our database connection works. We're probably checking that our Vogun generation works. Like, there's a lot of things that implicitly happen when you have a few tactical integration tests, which usually people throw in last. In clean architecture, a lot of the time I see just unit tests with a lot of mocking, a lot of just wasted time writing, a lot of boilerplate. Why not run a few really high-value integration tests that you kind of use even to help yourself? I was writing, for the next demo, I was adding in these integration tests fairly recently, and it caught like 5 different bugs in the domain code that I had. And it's just so poetic of like, I thought the game logic in the domain was fine, but then I wrote the integration tests, and it's a nice dev tool to help you of like, why isn't this giving me the status code that I expected it to be, right? Why is it throwing a 500 in this case? Like, it helps you write your complete code. So not only does it help you mitigate and kind of manage the risk, it also helps you write better code. So I like the double wins you get there. JK's got a quote.
Do you use test containers?
Yes. I've been on the mic. The answer is yes. It's fairly, I can show you the, what do we call it, boilerplate code. It's fairly simple. We've got a base class that all of the integration test files use. It uses XUnit in this case, so it's got the lifetimes, which is the startup teardown for each test run. In this case, I use Postgres because, again, I'm writing this code for my own projects so that I save myself time. You can change it out to SQL Server, right? There's some JSON options that every client should probably use. I want to serialize using web standards, and I prefer JSON strings. You can modify that for your app. And yeah, it just spins up a test container, makes sure to create a HTTP client that's easy to use, and then in this case, it's just creating and migrating a database. In a real app, you probably will end up with seed data and other things. You can just add that in after as generic code. I don't know how many people know about Respawn, but you can set those database checkpoints and restore to them instead of spinning up old data. You can do all of that, but this is just simple. It just creates a new container for each run, and then these protected fields let you use and query your running app. The test app factory is that whole web app factory thing I mentioned, which just replaces the normal connection string with the test container one. So the test container spins up a number of different containers with different ports, and that just handles replacing the right connection string, because a few might be running in parallel. So that's all this thing does. And there's a random extension that just lets you write a few less dots to get a DB context. It's just an extension on the scope, which I can show you more once we go through the tests. I think there's a few more complex examples. This one doesn't do anything extra. It says, okay, we tested happy path as a created, but okay, bad path, I'm sending in too many characters. It should probably give me a 400 instead of maybe a 500. Maybe I forgot to catch that, or I'm throwing an exception or something, right? Let's validate happy and bad paths. The to-do command here, this might show you a bit more. So yeah, we can seed some data. If we want, we can just add a DB context code in our integration test, right? Using a scope. We don't want cache data. You might fall into some failures there, and use that there. Does that answer your question, JK? Nice. Yeah. So there's a lot of tests in there. I won't really go through it more, but the key thing here is you can write really explicit and intentional code in your actual application code, and then your tests are there to help you code better, fix bugs. But the important thing is they help you, again, tests never stop you from having bugs, but they at least help you have a little bit more confidence when you're making a lot of change in your code. In VSA, we're refactoring a lot, code's moving around a lot. With integration tests like this, where we are just saying call an URL with this data, it's a black box test where the implementation details might change, but as long as, given these inputs, I get these outputs, and maybe this external service was called, then okay, we at least have some confidence that all of our application is somewhat working fine over time. Like imagine you start with 50 endpoints, and then over time you get 1,000, and lots of developers are on the team. They're refactoring a lot of code. Yes, everyone's being disciplined, but maybe people are making mistakes. It's hard to catch it. You never know. If you didn't have integration tests and you were just relying on discipline and people following good coding standards, like I mentioned, right? I thought I was coding well, then I wrote some tests and caught it. Imagine that instead of being in the context of the feature, you don't know that this random specific side effect would happen, but you have a integration test which might catch that. So the main thing here is just focus on those tests. That's why I mentioned when we were on the slide, don't worry about the red-green refactor yet, but it really is that important piece of VSA of it makes it easy to modify code because we're identifying risk, we're writing, again, intentional amounts of tests to cover intentionally different amounts of risk with those tests. When those behaviors get pushed down and the code changes, we have a little bit of confidence from our red-green refactor cycle. Okay. Now, there are some architecture tests to come. Fun fact for everyone, these are all empty. But with static analysis, you can test, simple things like something that is a child of a feature folder. It should have a suffix command or query. You can add things that aren't I hate having to remember things. If I can write code that helps me code review by a test failing because someone did a typo, or they're injecting something they shouldn't, or they're, let's say I have a service inside of the feature folder, to-dos, and it's some shared service, but there's a separate feature folder and someone's trying to add that in, then we can make that just fail and say, hey, the risk factor of this change, you should move it to the correct folder, which is a higher level, maybe the global common folder, something like that. Instead of...
Copilot is great at writing tests.
Oh, I love Copilot. They wrote half of these, to be honest, with some modification. Some people really hate writing tests with Copilot, which I think is fair, because it, again, looks like right business logic, but
You need to review it. But
you definitely, yeah.
something you're saying.
Well, that's the thing, right? It should be a co-pilot where you're still flying, but it can do a lot of the heavy lifting and you check it.
And if you write like 2-3 tests, it's then better because it knows how you want to test
Yeah.
things.
Yeah, JK said if you write 2 or 3 tests, Copilot gets better at writing tests in the flavor you like to write, because, yeah, Copilot uses your code as input data for the massive coding model and say, hey, based on my code, what do you think is going to write next? So if you give it that context of write in this style, then it'll do pretty well. I have Wi-Fi, we can probably even try out, like, if I come to the bottom here, I've written a few tests, we've got a few open. If I write fact, and then Copilot starting, we can see what it thinks, like, hey, updated to-do when not found returns not found, post this thing, the status code should be not found. Like, it wrote exactly in the flavor I wanted with the base class properties that you can't even see in this file, but exist. Like, it definitely gets really good once you have a few, so 100% JK. All right, I am going to keep going. So we looked at the to-do example. I'm going to speed through, for sake of time, the next example. So to summarize the simple app, right, keep it simple, refactor when is necessary. In this case, we're currently at the state, we have 4 endpoints, we're not adding any more features. Like, at this point in time, it should be super simple and we don't need to refactor much yet. We decided to refactor the DTOs, the response objects. That was the only one, really. Start with transaction scripts. Again, those 3 phases, transactions script, then a service layer, then maybe domain-driven design. We started with that, and that's working nicely. We really, really, really want integration tests. Start with minimal tests. Again, tests cost time. If you're a professional developer, you're being paid to add business value. Writing lots of tests may or may not be business value. So you always kind of want to run as lean as possible based on the factors. How much risk? You know, if this breaks, will it cost my company a lot of money, or will it just annoy some people for an hour? Like, we always want to be pragmatic in this architecture. Don't overcook early. Don't do those, 8 different layers of abstraction and injections and, passing the baton around 8 times. Like we mentioned with the automapper, you don't want things that aren't statically analyzable and you lose the connection between things. Like, out of the gate, that makes no sense. If it can be simple and it works nicely to be simple, just start like that, and when it's needed, it will become screamingly obvious what needs to be refactored and what needs more. So definitely don't overthink it. Just start with what might feel weird, especially if you've been doing things like clean architecture for a long time. Okay, we will look at actually what is the template's base code. It has a more complex example, but I will speed my way through it. So I am going to pull up the actual code. So in here, I'll make a new directory and we'll call it sample, and we'll cd into sample, and then I'll actually run the template, and then we can start sample solution, and that should pull it up in Writer. And let's take this over. So this is the same exact boilerplate that we saw from before. It has 1 source code project, right? 3 test projects if I stop right clicking, an empty architecture test, don't worry about that. The same global, common, and domain. In this case, the app has gone through a little bit more change, and in this case, it's got a lot less code than you'd expect for something that has a rich domain, but it does have a rich domain to kind of prove the point in a very simple example. So let me actually spin up the app. So I am going to open, I'm going to open the terminal in the big zoom in, and let's just run the app for a sec. I don't think the Docker file is here. It's up a few maybe. I think it's in the root. Yeah, Docker there. So let's just spin up Docker Compose and start the engine first because it will break otherwise. Docker will spin up in the background.
This is probably a quick, cheesy question. .NET Aspire when?
Well, I had a previous template that I was playing with Aspire for local dev, and when I get time, yeah, basically, yeah. Again, like I said, I write this stuff so that it's easy for me to use, and I know Docker well. Haven't had a chance to shove Aspire in with confidence, but I will because it's cool. Does hands up? Who's heard of .NET Aspire? A few hands, maybe 50%. Yeah, I don't know it too well, but it's a whole. It's got a lot to it. It manages containers and configuration between these containers in a local and cloud story. So it helps you spin up a distributed system locally and cloud with open telemetry and all of that stuff, which I don't know well.
Yeah, I think the easiest way to explain it is it's Docker composed with whatever telemetry you like to have running locally, with logger as well. So you're not only collecting CPU memory and all of that stuff, logging as well. And I think there's a few other things. It's like everything in a single window, and you can configure it with C# code. So how projects depend with each other, create resources and stuff like that. You can deploy these things with help of Aspire much easier to Azure and a couple of other cloud providers. I'm not sure if you can automate creating those resources on the cloud. I think that's still in progress, but it basically gets you like 80% done without putting too much effort into it.
Early days, there's a lot of community backing, like the AWS open source, dev people. They're building their AWS components, so over time it only gets better, right? Yeah, I shall. Now that this engine is up, I shall just run it to prove. Sadly, I have to run a YAML file with Docker. It's very sad. But I'll prove just what this app does first. So it's a tic-tac-toe game, right? There's some business rules. There's win conditions, stalemate. You can make invalid moves, right? So you place X's or O's in a 3x3 grid. So let's just prove it. I'll create a new game with name string, and it broke because the database doesn't exist. So in this case, I actually just want to paste in some code. For fun, has anyone used the .NET New tooling engine to create like templates? If you have, one thing I didn't know about is if you have these if debug or if something blocks, that actually runs inside of the template. So this snippet is actually ripped out of the template, which I need to fix. So when I'm debugging, I want this database to be created, which is what the error was. So I'll just restart and it will be fine now. So let's do take two, right? Okay, it's not working, that's fine. I won't bother debugging it, but essentially, right, there's a board, it's shown on the API as a string, so it'll show the X's and O's. In your database, you're probably not showing X's and O's, you're using an enum, so there's some changes there. When you make a turn, you pick the coordinate and what player, so maybe we're writing in an X or an O, and that's coming out. Now, I shall just show some of the code. So there's a lot of business rules in that game. This is critical to my tic-tac-toe app, the rules working. So it's in the domain here. We've got a lot of primitives, and it's all pure code, so it doesn't know anything external. In fact, the game object is an EF core table entity. So if we go to our AppDB context, this fancy object is directly a table, which is interesting, but we're writing it in a way that it doesn't really know about EF core. A lot of times you'll write a POCO object because you're using EF core. But here we've got things like a child class board object, which has a tile, 2D or jagged array, which one is which I forget, with some objects on it. We've got business rules on the parent, so when we create it, you can't have too long of characters. You make a move and if you've already won, it throws exceptions. There's lots of rules in here, lots of logic, which the pure domain doesn't need to know how this becomes done in EF core. But there's a risky common code that EF core does need to know, and it's risky because if this breaks, a lot of stuff might break, right? But it can manage all of that scary stuff. And that's kind of the end step of a domain-driven design style VSA, where you've shifted all of your logic basically all the way down to your domain. And when you have a domain like this, you have unit tests, heavily unit tested. So pure code, we don't need integration tests in this case. When you add in domain logic, then we unit test it. And when it's use cases, we stick with integration testing. So in this case, there's both simple integration tests and very wide unit tests. So this code is public. I won't bother going through it too in depth. But for complex apps, imagine I started with the game with one endpoint. I might have written the win condition check as a transact script, and then maybe there were a few different cases where when I wanted to view the state of the game without making a move, well, I want to know whether we've won or not, so maybe this logic needed to move to a service, and then maybe I wanted lots of unit testing or to shift it into the class for better use, and then maybe it became a domain model with unit testing. So, that abstraction became obvious because I needed these business rules in a lot of places, and I don't want to copy paste it around, so it's very obvious that we need to abstract this away from your use case and lower it down, right? And I think I've hammered down a lot of this, right? Don't overthink it. Don't abstract ahead of time unless you're really sure this is coming, but nothing's guaranteed. Again, there might be different business priorities where you really think you're going to do something in a month or a week, but then maybe you just drop it entirely. Like, it's all about pragmatic decisions, which is really what I'm just trying to nail down. So, when should we pick VSA, right? That's kind of the important thing. We've seen a little bit more about it, how it's really architected around reuse and the risk there and how you mitigate it, and then general patterns like CQRS and whatnot, which is honestly not too important. The risk and how you test around levels of risk and levels of reuse is really the important thing, and that all comes around your dev practices, right? So naturally, with that in mind, well, this is a quote, somewhat paraphrased, I think, from Jimmy's blog post, which most people would skim over. You look at the code, and then the 2 paragraphs at the end you're not going to read. But the suggestion here is, hey, if your team doesn't understand when a service or a use case is doing too much, and that you should push this down, in this case, to a service or a domain, then you probably shouldn't do VSA. It is all about dev practices, right? If your devs shouldn't or don't want to or couldn't handle lots of refactoring, lots of fluid code, then maybe this isn't the right choice. There is a lot of comfort in clean architecture being very distinct. Let's say you've got 100 devs in different time zones. Your tech lead might not overlap with a lot of those time zones. In clean architecture, if the question is, where do I put this code? How do I do it? And the answer is always this way. It just goes this way. There's a lot of comfort in that is just how it's done, and there's no wiggle room, right? There is risk involved with wiggle room, right? People can make mistakes, or they can make it a lot better. On the contrary, again, paraphrase from his blog post, if your team does know how to refactor, they can recognize when something should move from the use case to a service, from a service to the domain, how to do those different tiers of testing, then hey, it's going to be awesome. From Jimmy Bogard's words exactly, he says, hey, if you know how to refactor, then it can scale past those traditional layered, basically saying clean architecture, right? Or concentric architectures, which is that whole technical layering thing, which I think this talk has given the context for those 2 ending paragraphs, which most people wouldn't read of. It is basically telling you how to work as a dev and as a team, that if we all work in the same way, we can really, really be productive and pragmatic. So, in conclusion, the resources, this is the link to that template that has all of the boilerplate done for you. I've got a QR code that links to this presentation, which includes these links, so you don't have to screenshot this if you don't want to. The to-do sample, that exact sample I had with just the 4 endpoints and the simmered down transact script stage app, that's there. I have an example I didn't even show here, which is a very small sample showing event sourcing, MartinDB with VSA in this style. So, a different technical application with the same VSA architecture. A bunch of blog posts that is related to VSA. I think I linked this before. So, history of VSA as writing the automapper thing, getting started, that kind of stuff. Finally, obviously, we have to link to Jimmy's post. He coined it, he created it. We got to call back to him. That's definitely worth the read. If you've read that post before, I definitely challenge you to read it again with the context from tonight and see if you have any gotcha moments or insights. And then another awesome link, if you haven't seen it before, is this is a site by Mehdi. I think he just got MVP award, by the way. But he has a bunch of software architecture awesome links, so just a link to videos, articles, and everything. One of them is on VSA, so he links to a lot of great articles, videos, sample apps, and whatnot, so that's definitely worth it if you want to deep dive a little bit more on other people's flavors, because again, my template I use for myself is just my technical application of it, but what matters is the processes and the developer processes that you can't cook into a template. So explore more out there. If you want to scan the QR code, that'll take you to a place you can download this whole PowerPoint, which includes the links, of course. So I'll leave that up for a second. Yeah. Seeing some phones. I'll leave it up there.
Skip to the end of the YouTube video.
All right, nice. I see phones down. So that's the end of my talk. Thank you, everyone. I hope you learnt something out of it. And I hope it made you excited about VSA and maybe gave you a different perspective on the architecture, more than that basic, hey, put everything in this one folder, right? I hope you know at least somewhat deeper than that. That's really important to me. So that being said, thank you all. Any questions, any comments, any burning questions? Go ahead.
We have a mic.
No problem. The logic and how you approach all of this feels very similar to the domain-driven design. Yeah. So I was kind of I wanted to ask you, how do you put VSA compared to DDD? Does it come on top and it's an extra layer that englobes DDD, or is it side by side?
That's an interesting question. Like DDD obviously is, again, development practices, not write code, with these, fields and stuff, right? So how do you apply VSA when it's technical processes with DDD? My answer is I have no idea. I think they just work nicely together, where, to me, the nice story is you do TDD, right? It's written in there with the whole red-green refactor as a core of it. TDD, DDD, VSA, they all kind of work nicely in synergy to me. I don't know if there's a pros and cons and weird caveats, but yeah, I don't see them conflicting. But yeah, it's a good question that I'd want to explore further. Yeah.
You made a comment about when to use VSA, and you said if you know how to refactor, you can scale far beyond traditional architectures. Can you talk about scale, what you mean by that?
So this is a quote from Jimmy's blog post. So that's him saying it will scale past it. To me, my understanding of that is, if you're building code in such a way that it's heavily abstracted always, and maybe it's not always, the lowest amount possible, then I feel like there's going to be a certain point where your lead time slows down so much that it can't scale over time anymore. And to me, that's where this is the whole, okay, well, if you're always doing the least amount possible and keeping it as simple as you can and as readable and optimized for a developer working within a system, then to me, that's where that whole, you can scale far beyond it, because it is really dev friendly, and maybe you have less slowdown over time. Yeah, that's my understanding. Anyone else? One at the back.
Yep. I have a question when so thank you first for the presentation. It's been very clear, and I feel like we all could have spent another half an hour listening to going through your passion. I understand that it's all about simplicity. That probably, from my understanding, gives a perspective on code, how to be narrative, to make it involve and think about it and refactor it as you go and not in advance. Now, I have a question in an enterprise business. We all arrived sometimes in projects where it's a whole spaghetti plate, the code. And could you give us your perspective on what are the metrics that could indicate that vertical slicing could be a possible option for the team to work with? Maybe there is other ones, but yeah, to bring to...
Honestly, the main metrics of if it's a good option is if your dev team is passionate about coding and cares about the business to some degree. If that's because they're being paid, that's fine. But if you care about coding and have some pride in your work, I think that's where, when you empower your devs and they care about the code, if they're forced to write in a certain way, you might knock them down and make them unhappy and therefore less productive. But if they're passionate devs that love coding and you empower them to, hey, you can make the decisions about how this works, but follow these few general guidelines, then I think that's where the metrics are like, hey, this might work really well for your team because, hey, these 10 devs all love to code. They're getting paid to do what they enjoy, but they have to code in this certain way. Why don't we see what ideas they can come up with? To me, that's a pretty awesome indicator. I don't know if there's other metrics that are measurable, because again, for a technical architecture, you can measure technical metrics, but for a more heavily process or people architecture, to me, then I guess you have to measure the people, which is where the whole guidance that Jimmy ended off his initial article with. The guidance is basically based on, do they want to refactor and handle lots of change? So to me, yeah, it's just about passion and care and pride in your work.
To and from VSA would be a whole nother talk.
Yeah. The migration story is a whole nother talk, but I think it's easy, not easy. I think it's doable to migrate from a monolith to VSA, because you just start, again, the whole VSA thing is about refactoring, right? So if you start refactoring into a VSA style app, you start to go from lots of interconnection where it might not be clear, it might go up and down and sideways, to slowly ripping it out to, you're starting to be careful with how shared something is, how risky it is. As you build into this VSA style, you start having integration tests and that kind of coverage around pieces. But yeah, that's my general thoughts. Anything else? Don't think so. Awesome. So I shall hand it back over to Todd. Thank you.
I'll go around this way. Thank you very much, everyone, again for coming along. I just want to thank our sponsors before I forget. So obviously Telstra Purple, who are so kind as to lend us their venue every month and have been doing so for quite a number of years now. So thank you again, Matt and Telstra Purple. Secondly, we've also got JetBrains, who sponsors the user group, and we get to give out a couple of 100% discount codes for JetBrains IDEs. So you can obviously get Rider like you saw tonight, or you could get a data grip for your Postgres, for your MartinDB stuff, or whatever suits you. So would you like to hand these out to your two favorite questions from tonight?
I can do that. Who asked a question and doesn't have Rider? We usually go through this. Everyone has Rider. So hands up, who just doesn't have a JetBrains?
There's a gentleman that asked a question down the back. I'll be your runner. Take a second one.
Yeah, you asked the question, so here we go. 2 out of 3 questions got. Nice. All right.
Okay, so thank you again, Luke. That was excellent, and I think you might have converted me this time, whereas last time I was still a bit on the fence. So happy about that. Just want to have a couple of quick announcements. We don't have any speakers for next month, so if you have something .NET related that you would like to talk about, whether it's 2 minutes to 5 minutes, 20 minutes, an hour, JK 2 hours, whatever, then JK might come back next month and talk about AI stuff maybe, but we'll have it's quite a short talk, so happy to talk to you after the user group. The other thing is DDD Brisbane is coming up in December, at the start of December.
First weekend.
First Saturday in December. It's on at Brisbane State High School, if I recall correctly, which is just over the bridge here. I think it's 300 to 400-ish sort of attendees, something in that range. Most of the talks are of a technical persuasion. They might not necessarily be .NET related, but they'll be technical
It's open to anyone.
data design, development, etc.,
It's open to
etc.
anyone. It's by vote. Unfortunately, we've just missed the voting, so if you haven't gotten in yet.
Don't worry about it. Someone else has done the voting for you. You just come along. It's $49, right? So it's a community conference, and I think you get lunch and you get some other things as well. So it's super cheap. So if you've never been to DDD and you're looking for a community-driven conference for $49 for a whole day, it's super worth it. So Google DDD Brisbane and you can buy tickets. You get free swag, yes, which is the main reason to go.
Vote bag and.
Yes, that's right. So look, we're here every month, and one of the hardest things for running a user group is finding speakers. So if you are interested in, like I said, anything 5 minutes, 50 minutes, it doesn't matter. Please just reach out to us via the user group on Meetup, or obviously have a chat to Matt, Cam, myself any time after or before the Meetup. Thanks again. Hopefully see you next month. Cheers. Thanks, Luke.